What's barium titanate by Silas Baker. Barium titanate. Barium titanate is an electrical insulator that can be polarized by applying an electric field. It's also a highly strong dielectric. Being the versatile ferroelectric ceramic material it is, barium titanate is best known for its exceptional electrical properties, widely used in capacitors, transducers, and microphones, as well as other sensors. It's also a piezoelectric material, which means it accumulates electric charge as a response to mechanical stress. Manufacturing process or synthesis routes, solid state. In order to be used in its various ways, barium titanate first has to be synthesized down into a powder. This is done in a couple of different ways, one of which is solid state reaction. This process involves high temperature calcination of precursor powders like barium carbonate and titanium dioxide. Although it's easier, this method requires high temperatures and in some cases can lead to larger agglomerated particles with less chemical homogeneity. Manufacturing process or synthesis routes, wet chemical. On the other hand, wet chemical processes offer more control of the actual particle size, morphology, and purity with significantly lower temperatures. The hydrothermal process utilizes aqueous solutions of barium and titanium precursors under high temperatures and pressure to crystallize barium titanate directly from the solution. Sol gel processes involve the hydrolysis and condensation of molecular precursors to form a gel, then being calcined to produce an oxide powder. Co-precipitation is the precipitation of barium and titanium species from a solution, often in the form of oxalates, hydroxides, followed by calcination. Where it's used, electronics, capacitors. Due to its unique properties, barium titanate is used in many applications, one of which being in electronics. Due to its high dielectric constant and piezoelectric properties, it is widely used in capacitors, multi-layer ceramic capacitors, and electro-optical display panels. Capacitors are electronic components that store electric charges in electric fields. They consist of two conductive plates separated by a dielectric material. When they can connect to a battery, they can charge by allowing electrons to flow from one plate to another, storing energy for later. Capacitors play a crucial role in electronics, as they can release stored energy when needed, making them essential in applications like filtering, timing, and energy storage. Where it's used, electronics, transducers. Another use for barium titanate is in manufacturing piezoelectric transducers and electromechanical transducers, including microphones. These types of transducers convert electrical charges into energy. Just a few other examples of piezoelectric transducers are seismographic measurements, sonar systems, and piezo-auto actuators in cars, which turn the electric signal into a stroke, adjusting mirrors and lenses. Where it's used, electronics, thermistors. Another one of barium titanate's various uses is in semiconductor-based resistors sensitive to temperature, otherwise known as thermistors, along with temperature coefficient heating elements by being manufactured with dopants. This gives the material semiconductor properties it needs to be used in applications like fluorescent lights, automobile cabin air heaters, consumer space heaters, as well as overcurrent protection for motors. A dopant is a substance used to produce a desired electrical characteristic in a semiconductor. Where it's used, electronics, thermal cameras. With its pyroelectric and ferroelectric properties, barium titanate can also be used in uncooled sensors that are fitted in thermal cameras. The best way these work is through converting infrared waves into images that show temperature variations. These thermal cameras can be in return used for industrial inspections to detect leaks, for search and rescue missions, for firefighting missions, and for some electrical wiring maintenance. Where it's used: electronics, NOx sensors. Barium titanate has many uses in the automotive industry as well, including in the creation of NOx sensors. NOx sensors detect the vibration and timing of explosions that are being created in the engine before converting them into signals, which are then sent to the engine control module. This prevents engine knock, which could damage the vehicle's engine and potentially cause danger for the driver and passengers. As you can see, barium titanate provides assistance in a wide range of industries, all the way from automotives to healthcare. Where it's used: healthcare, nanocarriers. Barium titanate also has biocompatibility properties, meaning it's a good tool for being a nanocarrier for drug delivery. This involves barium titanate nanoparticles taking drugs to specific areas of the body, carrying drugs that are either absorbed, dissolved, entrapped, or covalently affixed to the surface of the nanocarrier. Its role in being a nanocarrier for drug delivery makes barium titanate hugely useful, allowing certain medications to reach sites of the body that would otherwise be inaccessible, like the brain or in specific tumor sites. Advantages: barium titanate, unlike polymers and other ceramics, offers a higher dielectric constant, which ensures better performance. It contributes to a lower production cost due to its abundance and processing ease. The ability of barium titanate to maintain its stability under different environmental conditions further proves why it's preferred choice for capacitor application. Disadvantages: despite the advantages, the use of barium titanate does not come without its disadvantages. Unfortunately, the material exhibits aging effects, and its properties do tend to gradually degrade over time. This has started to stir up some research into improving the product's longevity and reliability. There are also some efforts being made in the direction of developing new composites and changing existing structures to better their performance. New innovations in nanotechnology and material science are opening up new gateways for improving the properties of barium titanate. What's on the horizon? The future for barium titanate in the electronic component industry is looking bright. As demands for more compact, efficient, and robust electronic devices rise, there is an equal need for advancements in materials that can meet those requirements. Barium titanate is positioned very well to remain at the top of capacitor technology. Researchers are over the top about discovering potential new modifications and needs for barium titanate, broadening its use beyond traditional capacitors. And here are my sources.